Imagine yourself working in emergency services and you got a call. There is a building on fire, earthquake happened somewhere, or a building got collapsed. What is your first reaction in this position? I know it's a hard feeling, but let me tell you from my experience during the Syrian War 2012. I was among those people running every day if a place got bombed behind my house. We run with free hand, filling our throat with one question: anybody alive down here? No fear from death, but fearing if someone left behind us with no help. In addition to a quick search on the website ICMP shows that more than 60,000 persons missing since the Syrian War started. In addition to 600 significant earthquakes happened during the 21st century, causing more than 5,100 death cases around the world. That's according to Significant Earthquake website. All of this make me think about we are in 2020, why not to start EIH? What EIH aim for? Simply, number of people inside the building, where emergency exit, area size, levels will be considered for next releases, where this website will allow the emergency services to prepare to, respond to, and save more lives during emergency events. So how? We do have a building and our device set on the main gate to track the number of people walk in and walk out. Then we save this number on the cloud, and at emergency events, the emergency services will ask the cloud how many persons inside this building. The cloud will respond with the number. Now the emergency event has a better understanding what they are facing and they could prepare for it. So in more details, a person walk in toward the door, touch the first sensor, the second sensor, then he's in, then the camera will take a picture for him. Then, since the picture got taken in both directions, a body detection algorithm will run and check how many persons in this picture to take the number and save it on the cloud. So to start the demo of this project, we have to follow the instructions on GitHub about the hardware collaboration and how to fit these items on the wall and how to adjust them to get the better performance. Let's check on the real life. Now I have connect the sensors and the camera, and I set up the camera in a good distance from the virtual door I made. So this door is 25 centimeters width because the IR beam breaker sensors I got, they are 25 centimeters width. I couldn't fit them on the actual door because the door is 60 centimeters width and I was not able to get this kind of sensors right now during the lockdown. So I got these cables, I connect them to the Raspberry Pi, I made a good distance from the camera to the door, so if people walk in, I would be walking as myself for the demo, and I would be able to detect by the camera, and the body detect algorithm will work. So after we connect the hardware, we have to go to the front end right now and log in as an admin. Since we log in as an admin, we could add the new building right now to the system. A click on new row will appear on the top of the table. This new row will take the address, known name, and their code. The address is supported by Google Autocomplete. Let's add any building. Let's start with Apache as I had food with Apache today. So Apache Temple Bar, copy the name, paste it on. Then we get the air code. The air code it's not officially used in Ireland, so we can't depend on it. We can add any air code and we could say add. Since we add the address to the building, an alert will come back which says this building has been registered with this registration key. This key is important to go to the back end side, configure the Raspberry Pi, and establish the connection between the front end and the back end. So now, after we add the building on the front end side, we have to go and configure the device to make it run and install all dependencies. So on the README file, I have explained how to install all dependencies and how to run the file. So in the subfolder for Raspberry Pi section, we have a number of files. One of them is setup.py. This file has been created to make an easy installment for all dependencies. So Python setup, and that will start the process to install all dependencies. So Ctrl C to save the time. Setup has been done. This is the message to tell you that all dependencies has been installed. Once it's installed, we have to export the registration key we got for the building on the back end to establish the connection between the front end and the back end. So I do have the key over here. Then we Ctrl V, we have them already right now. So I have exported the registration key for IT Carlo to run the process right now with an IT Carlo with 112 person inside the building. So to run the project, I could run the project as an in direction and out direction. So if I run the project as an in direction right now, so I have to go to the main file eihir.py and give an argument as an in. So since I give the argument as an in, my project will be running as an in direction right now. Everyone will be walking, as I will show in the video later, will be considered as an in. The number will be incremented from 112 to 113 and 14. Let's go and see how. So right now we are walking toward the sensors, and we got the sensor 1, then the sensor 2. The picture will be taken and the body detection will be work, and we could see here right now we have one body has been detected and data stored on the cloud, and the number of people is 1113. That's for the actual building we set up. Right now we're gonna try again. So we have the project works, and we have the sensor 1, then sensor 2, then the picture start to be taken and the pictures get processed, and as we see the number right now is one person has been detected and the number has been incremented by 1, so we have 114 right now. So now let's test the project in the other direction, in out. So to have the full system working, we need like a set and package of hardware to run as an out, another package to run as an in, as I've described here. Then we have the full system working at the same time for in and out. Let's try as an out. Now after we run the file on the out direction for the same building in the same set of hardware, because the limitation, we have only one set installed in my room. So and right now the people who walk in through the sensors and get detected by the camera will be considered as out. So if I walk in by the sensor 1, then sensor 2, the body detection will be working and I will be detected as one person, and we could see right now here the number back to 113. So because the number stored in the cloud will decrement by 1 as I was walking out, then the number is right now 113. So now I will run again for out. So as I have said, right now this system is linked to IT Carlo and we are working right now. So if we walk by 1 and 2, the picture will be taken, and we could see right now we have one body has been detected and this person is going out of the building. So we have right now 112 as a number of people inside the building, because 2 has been taken out and 2 people walk out. In addition to this, I have a number of features implemented on the front end to make the user input much easier and straightforward. The main page of EIH designed to be simple and to not distribute the user during emergency time. It takes one input. This input, as the person type in, the list of Irish addresses will be listed from Google API to select one of the addresses and easy click search. Once the user clicks search, the result page will appear. The result page showed the number of people inside the building, the building status, and the address. In addition to this, it showed the Google Map API to easily get the directions and straightforward to the location. The menu page designed to be closed all the time. That's to not distribute the user during the work. When I click on the menu will open with number of tabs like the home screen, location screen, about, case study, and contact. On the menu and the location tab will redirect to all locations page. All locations page show a table for public user with some information such as building name, address, air code, number inside, status, and last update. This data could be public or private depending on the controller of this website. If you log in as an admin, you will have a different of options to control this table. The power of one used in this table. You could use all different options like reset, add, delete, activate, update, new row from the user, all in one place, so you don't have to go to another pages. One of the admin options is to reset a number of people inside the building to 0, and that's by right-click, reset. But because the data is sensitive, you have to do double time check. First time is to select the building, second time is to reset with confirmation yes. Then the number will be back to 0. This table allows the admin to update the location and the details in one place. So select the location first, then click on the field you would like to update, then update as you like, right click, update, then confirmation yes, then the place will be updated to the Facebook Dublin. The status value on this table represents if this number is live or not. True means this number is live, false means this number is old and the device is not in use. To put a place from true to false, select the place, then right click, delete, and confirmation yes. The place will be set back to false. To reactivate the place, select the place again, right click, activate, OK. The login page will allow the admin to log into the system and control it. Registration is not one of the options as it's not a public website. To register a new admin, you have to go into the Firebase section, Authentication tab, and add a new user. Then the user will have the login username and password and is able to log in. That was me, Usama Abu Hajar, representing my final year project with 10 minutes. With full of hope, this project will be able to save lives around the world. You could always refer to the YouTube library for more guidance and instructions about how to set up the project, or the instructions on GitHub by README files. I would like now to say big thanks for my supervisor, Paul Barry, for all the 9 months of hard work, and all the other supervisors for their guidance and help over the years. And I would like to thank all my lecturers for all the 4 years in IT Carlo. Thank you very much. Shukran.